RDT, EPT, paper వేసావా లేదా ఇవన్నీ మాట్లాడు.
Surendra garu, are you there? Surendra garu?
ఏమైనా ఇంక్రిమెంట్ అడిగారు అనుకోండి, కొంచెం ఏంటంటే కోరుకున్నాడు.
Anjali, please put everyone on mute. And I'll just, while the CEO of APITA joins, I'll just brief few aspects of what is this course about and how it goes every day, and how is the assessment done and the certifications provided. So I'll just brief it for a few minutes and then we will start the class. So good evening all faculty, and most of the faculty I'm sure must be knowing Blackbucks, and I myself have interacted with number of faculty earlier. So good evening everyone. A quick 2 minutes about what this course is about and how we'll go about this course. And before that, as you all know, Blackbucks is a prominent edtech organization in higher education space. And we work in emerging tech areas like artificial intelligence, machine learning, data science, cloud, cyber security. And because all faculty are here, Anjani, can you please put
consideration?
So as people who are working closely with industry, and you're all faculty who are who work very closely with students, I would like to tell you that the most importantly, students have to learn full stack development, because that's where organizations are still hiring in. So that is very important. So we also work with full stack development. And our flagship project is, we have a product called TapTap. This platform is for premier placements for the students. It's total analytics based system which will give strengths and weaknesses of the students month over month on how they are improving. Every month it will check, in all the aspects that an organization tests for student hiring: aptitude, reasoning, English, listening, speaking, reading, writing, and most importantly, programming in almost 10 languages. So we have a content development team that gives strong challenges to the student, and the student will be given employability score. And we share these scores with organizations. We also select top 100 from your college, prepare them for these placements of high pay placements. That's our flagship project. But as all of you must be knowing, we are very well known among faculty, that to computer science and artificial intelligence faculty across the country. We also get, whenever we are doing FDP, we also get faculty participating from other countries. So that's about us. I put very brief introduction about us. So this policy which we are just talking about, but to all faculty and professionals, I don't need to tell you, that's usually for students and all. Please maintain the transparency and authenticity. What we have seen in our earlier faculty development programs also, that some faculty don't attend the class, they just want the certificate. So that's not important aspect here. We are taking the effort to pull in Molly for this advanced lessons for faculty development. So kindly take advantage of the workshop and the faculty development program that we are conducting. And best policy is transparency and authenticity. If there is something that you are not following, or if something that's going wrong or you don't like, or something is fast or slow, please give your honest feedback. Be upfront in your feedback. There's no issue with that. We want to correct and make it best suitable for you. So please give the best possible feedback. No, don't need to give the highest feedback. Please give the right feedback so that we can correct. And please take the information that we are presenting here, the presentations, the videos, as confidential and proprietary information. Please keep it within the group of people who are attending the class, who have all registered. Around 350 people have registered for this program, and please keep all this information that we are giving as treat them as confidential and proprietary. The course schedule and attendance. The schedule is as follows: Wednesday 6 to 8 p.m. today, tomorrow and day after 6 to 8 p.m. This is 6 hours, and Saturday it's 4 hours, 10 a.m. to 1 p.m. Attendance will be given to every day. There will be a quiz, and so we will be taking attendance through the quizzes and exercises that you submit. And please fill the feedback form. Some days it is just the feedback form. You will not have any quiz and exercise. Please fill the feedback form on that particular day. Please be on time, and makeup policies like this. If you are not able to attend the class, please let us know. You will be having a lot of works every day, I'm sure. So if you are not able to attend the class, please let us know on the support number that we will share to you in the WhatsApp group, and you can complete the quizzes and exercises. We will share to you the recorded video, and you can complete the quiz and exercise as per that. Certification will be given based on your everyday quiz exercise and final quiz and exercise that we'll be giving, and the certification will be given by APITA and Blackbucks jointly. Certification contains a mention of your performance. There will be 3 different bands: satisfactory, excellent, and outstanding. These are the 3 different bands that you will receive depending on your everyday performance. And please share extensively on your social network, and be proud about learning this. This is an advanced program and advanced session, so be proud about it and share your achievement and the certificate that you get extensively on social media. The course material in TapTap, you might have all registered to take the pre-assessment. In TapTap, all course material will be available. The videos, links, reading material, pre-reads that you have got today, and also the assessments and quizzes, everything will be available at one place for you in TapTap. As I said, please use it fairly, restrict to fair use. Do not share extensively to people who haven't attended this program. Anyway, they won't use it, because if it is just knowledge, it will be everywhere in the internet. So please keep it to just to the group that who are attending this program. Okay, and communication. So don't panic if there is something is not working, you're not able to take an assessment, or you haven't attended a class. Please send messages to given phone numbers. We will share it in the WhatsApp group. So we'll give the phone numbers for individual issues. Please text to those people. They are support people. And all other faculty will be panicking if you put it in the group. So please put it separately to those people, to the numbers that we have given. They are customer support, and they will help you out with the issue. If your issue is not resolved, then meet Anjani Golla. She is also there here. She is the program coordinator for this faculty development program, and Anjani will be able to help you out with that. And even if she is not able to resolve that, I'm always there. Please text me. My number is given there, and probably many of the faculty must be having my number. Please text me. And office hours close before 9 p.m. So any issue that you got, we will try to close by 9 p.m. But after 9 p.m., please allow us time till the start of the day. Probably around 10 a.m. we will be resolving that issue. Lastly, be respectful and professional. This is general, not for faculty, are usually more respectful and professional than any other person. So please be respectful. If you have questions, email contact@blackbucks.me, and this is my number. Please note, if you need any information or any escalation, please let me know. And we are located at Jubilee Hills, Hyderabad, and also in JNTU, Kukatpalli, Hyderabad. We are also located in Vijayawada and Tirupati. Okay, this is about the program on the whole. Any questions? Probably you can ask me now, or I will hand it over to the CEO of APITA to just take 5 minutes to welcome you all. You can ask me any questions if you have, or I will welcome Dr. D.V. Ramakot Reddy garu. Okay, so Surendra Garu, are you there? All right, so we'll hand it over to Mauli, Mr. Mauli. You all know Mr. Mauli is one of the favorite faculty development program executives, and he has done number of faculty development programs for us. That is what I was mentioning across India and outside India. When it is Mauli, people attend, and he himself has run an organization which is into large language LLPs and artificial intelligence. A very fine executive and very fine leader in artificial intelligence space. Thanks for joining us, all of you, and I'll hand it over to Mauli.
Thank you very much for kind words, Anuradha Garu. And good evening, everyone. I'll share the screen now. I didn't expect this problem. Okay, you're able to see the screen?
Hello,
No, sir.
I'm Ram Reddy. Can
No,
I?
sir. Go ahead.
Hello.
Yes, sir. Yes, sir. Now it's our.
Yes, sir. Please go on, sir.
Okay, fantastic.
Mauli,
Go ahead, sir.
Mauli, 1 second, Mauli. Mr. Ram Reddy wants to speak.
Hello. Good evening, everybody. Respected Anuradha Madam from Blackbucks and the faculty from Blackbucks and the faculty of various engineering colleges and the members of APITA. Good evening, everybody. As you know that APITA is reinstated all the programs to train the students as well as the faculty. And I welcome all the faculty members for this program. And I am thankful to Anuradha Madam and the team of the Blackbucks for organizing this event. We all know that the emerging technologies are dynamic and they will change from day to day, as well as the applications and the pattern itself will changes from application to the application. And all these are full stack development and other things will vary from one domain to the another domain. As we have recognized 37 domains, and IT and ITS is one of that one. And we know we are all know that software is penetrating to each and every field, and the artificial intelligence, data analytics, and all these things are penetrating one by one. So the service sector and research and development sector are exhausted, and the applications of the IT is penetrating to the other domains like medical,
Sir, your screen
logistics.
is not visible, sir.
Okay, I'm by my mobile, so please bear with my voice only. Okay. Hello.
Yes, sir. Please go on, sir.
So every day the faculty which are guiding the students or which are doing enriching the students, they have to know what are the dynamics and what are the changes from day to day in the respective technologies. So the industry people only can predict and forecast what are the technologies that we what are the changes in those technologies coming and what are the different applications they are going to be applied, and where these applications will play the major role, and where these applications will create a lot of jobs. So ultimately, every faculty or every college institution has to show a beautiful job to their students or to make them an entrepreneurship. To do these two things, we must know what are the changes, what are the dynamics, and how the technology is going to be applied in near future. At least for the next 3 to 4 years, what are the changes that is taking place in the companies like HPCL, Infosys, and all those things? They are saying that the most of the jobs will fill with full stack development with Java or other platforms. So, and mostly with the embedded systems also. For that also, we have to apply the IT related applications to in that sector. So to know all these things, we must be enlightened with, or we must be have the brainstorming sessions with the people from industry. So we all know that Blackbucks is doing this type of sensitization meetings, sensitization workshops for the long time, and ma'am is well known to all the engineering colleges, and they are doing the placement activity also. So the Blackbucks is the, I thought that the Blackbucks is the one of the right organization to create, to sensitize the faculty so that they will transform the dynamics of the technology to the students, and students to get the better placements in their life. Okay, so I request all the faculty to utilize this opportunity and transforms the what are the things that you learn from this workshop, and transform it to the students, to your students, so that they will be enlightened. Similarly, we are also planning to conduct the workshops, online sessions, and the different courses from the different organizations, especially from the well-known and well-experienced industries like Blackbucks, HCL, Infosys, on the foundation. Like that, we are bringing all the companies to one platform, and we will consolidate into 3, 4 groups, so that the student can easily expose to one platform, and he will get a good placement in the near future. All we know that today we are having a great recession and no company is coming forward. But when we're talking to the companies, the recession will be ended by February of next year, so that if by that time, if we make our students ready to seek the job, then it will be a great success for all the engineering colleges of AP and APITA also. Once again, I am thankful to Ma'am Anuradha for organizing this workshop, beautiful workshop. So I hope this workshop will be a great success. And if you can, the faculty can transforms the dynamics of the technologies to your students, it will be the great helpful to the APITA, so that you can APITA will get the energy to organize this type of workshops in future also. Thank you very much for giving this opportunity. Once again, I welcome all the faculty for these workshops. Thank you.
Thank you, sir. Thank you so much. Mauli garu, can you start off the class?
Yeah, thank you, sir. I think it's quite inspiring, and also you providing how the future is likely to unfold is excellent. Thank you. All right, so the way we will structure, one, I'm very happy to be part of this dialogue, and I'm sure many of you are already working with different models. The objective of this dialogue is to appreciate how the NLP is transforming AI. So AI has been going through winters, and suddenly the natural language processing brought about significant difference in the way the AI is viewed. I think the first big breakthrough has been in the computer vision with companies like Tesla, and a lot of object detection and image recognition models have been very useful in real time. And now, while NLP has been in vogue since 1960. I think for the first time, I can say in the last 8 months, we see more credible processing capabilities by the machine, which can match to human, which can comfortably converse with humans. So I think we are at a very interesting phase, and the whole focus is around this. What we will also do by end of the session, we'll ask you, there are different dimensions from which we can see NLP, and which one you like to spend more. We will decide that. And today I will give an overview, and please use the chat to share some of the questions that I ask, some feedback from you. Is my assumption right that all of you are familiar with machine learning?
Yes, sir, somewhat.
Oh, fantastic. So then we will spend some 5-10 minutes, excellent, 5-10 minutes about machine learning, and we will go into what NLP. Today will be relatively easier. However, as we progress, we will determine. Okay, even before we get to the agenda, let me share a few details of. So the slides and a lot of content that I use, and in the next few days, we'll use the code that is heavily adopted from Christopher Potts and Chris Manning. Both are Stanford professors. One teaches NLP, language processing, and other teaches NLU. Last 11 years, Christopher Potts has been teaching. Vamshi, my colleague, he's been supporting with a lot of data here that I show, and internet. Now, one big difference that we have been exposed to in machine learning is, unlike software, where we decide and we provide the instructions to the model, and we expect an output through data and those instructions. In traditional or software programming, in machine learning, we only provide data and output. The rules are expected to be determined by the model itself. So the way, an example could be, let's say we have a Word document and there is a paragraph. You want to copy and paste it. So you highlight the text and go and click an object that copies another object that pastes the content. Now, behind this object, there are many lines of code, that instructions that get executed. Those instructions are a typical traditional programming. If I have to take a machine learning illustration, let's say there is a basket of apples, and we want to find if there is an apple, let's say size of it, if it is smaller than acceptable size. And we don't determine the sizes of the apple saying the length, breadth, and width. Instead, we provide all the apples, both apples that match to the size and apples that do not match to the size. Only thing is we label them, saying these are all matching acceptable size apples, and remaining these are the apples which are not acceptable. So what we are doing is, data here is apple, output is the label, acceptable and non-acceptable, and we push it to a machine learning model. We could take any of the statistical approach or mathematical approach. And we expect the rules are determined by the model itself. So I'll keep moving from slide to slide and share. If you have a question, or if you want me to repeat while I'll keep giving pauses in between, you highlight it in the chat. Now, in this case, we generally the way it could work, it could likely to work is that it will see the sizes of apple, and the bigger sizes are all being acceptable, and the smaller sizes are not being acceptable, and that's how it is likely to set up rules. The important element here is those rules are determined by the machine itself, by our software itself. We are not determining those rules. Now, there are AI winters where there is a big hype, and again, we realize that it is not really usable. Unlike traditional methods of programming, here, the machine learning is not always deterministic. One, sometimes it is probabilistic. So probability, the likelihood of something to occur or not occur is not accurately been identified in the past. Today, it is in the last 5-6 years, AI has become, I can say since 2011-12, has become mainstream primarily due to these three factors. One, data. And any guesses where we are getting the data now?
From social media.
Yes, social media, internet. Now you have a large amount of data. Yeah, some of it we cannot say whether it is a fact or fiction. However, the access to the data is tremendously high today. And processing capabilities have significantly improved. In the smaller and smaller sizes of chips, we are able to handle much more capabilities, processing capabilities, multi-core and so on. And similarly, storage, if you see on the right-hand side, I think storage also from floppy disks to current SSDs, and their capabilities to handle petabytes and terabytes petabytes and exabytes is extremely high. So due to this, what was otherwise been a difficult proposition to compute became super easy. We can store the data. For training models, we need a lot of data, and we need to store them, and we need to process. So these three, I would say, are the core pillars for AI today to become mainstream. Yeah, agree. Now, what we are doing, machine learning framework, if I have to put it in one line, something like in calculus, we say there is a data available input X, and Y is something that we want to find. So Y is a function of X. We transform the input data in a way that we will find. So what I mean to here calculus is dy. So for a given dx, what would be dy? So y is a transformed value of x. So the input is within, and whatever transformation that we use in a linear regression model, the transformation we use is y is equal to mx plus b. So we add the slope and a bias where the value is intercepting. So in real world, we will not have exact relationship between x and y. So you have some bit of bias. If you look at if the value that we are predicting is a sentiment, yes or no, a binary classification, then we would use a logistic regression where the relationship between y and x is y is equal to 1 by 1 plus e power minus mx plus b. So essentially the transformation approach would vary dependent on the value y and the problem that we are solving. However, the framework remains unaltered. It is whatever we want as an output is a function of or transformed value of the input itself. In machine learning, we have both training and testing, and a lot of work today in NLP is happening around evaluation of methods. We will, as we progress, we'll talk more. But generally, when you here, the rules are coming by the rules are being determined by the machine itself, by the software itself. Therefore, you need to have adequate data to test whether the rules that are defined by the software are relevant in different contexts or not. There's one more introductory thing that I want to share is any ML solution has these three steps. One, we attempt to identify a pattern between input and output, between y and x. And two, when we attempt, generally you initiate with some sort of initializers. With some random values, we try and establish relationship. And I'm hoping you agree with me, the output of any model, when we say it is the rules, the output is always weights. This, in the example of linear regression, it is the m and b. These are the coefficients. Coefficients or weights. The larger the number of weights, we say that it is likely to provide superior performance or superior accuracy for y, to predict y. In any case, rules here are those coefficients or weights. Now, initially, we have those weights as some random value. So we try and identify a pattern, and that pattern is either a linear regression or logistic or a tree-based model, something like a random forest classifier. Now that would be the logic or approach that you use to transform, but then you will, once you identify the pattern with some method, we are likely to have a deviation from the actuals. Now the second step is computing the deviation. There are different methods by which we compute the deviation. When y is continuously progressing variable, where a continuous variable, then we use the loss functions or error functions like root mean square error. So root mean square error is one option that we could do to compute the error. If the y is let's say binary classifier, binary value 0 and 1, then we use a log function to do. So loss entropy function we can use. If it is, and so on and so forth. The different loss functions we use here, or you may use the term cost function or objective function or loss function or error function. All these four terms essentially mean computing the deviation. Once we know what is the deviation, the next step is about iteratively reducing the deviation. And there are some lot of efforts that went in here. We call it as gradient descent methods and using back propagation and so on. All those methods are essentially reducing the error. Whatever we predict has to be similar to the actual. So here I spoke about, we test the data. We use some method to train the model, but then we test whether it is accurate or not. It is at secondary level. But within the training itself, we have these 3 steps normally kept. All right. Now, before I go to the history of NLP, any views or questions on introduction to machine learning? All right.
No, sir, all good.
So now, hello, ma'am. Good. So let's say human language, when is it formed? Roughly, we say that the humans have somewhere in East Africa, about 250,000 years ago, the human race has emerged or over time evolved. And there were initial, let's say about 100,000 years ago or 150,000 years ago, there was some sort of a sign language that started. Now, the written language has started more recently. That was about 3,000 or 3,500 years ago, where the language is written somewhere, and that was able to transcend the time and space. Earlier, when humans were interacting, it was then and there. Now, when we write it somewhere, now it can go beyond the current time because it can be stored and it can also be moved to another space. There is a big shift, and it took so many, probably more than 100,000 years to be able to move to the writing level. Now, in case of computers, the computational linguistics that we talk about here, they emerge very, very fast. And the speed at which they emerge, and we call it as large language models. These large language models today, that GPT, it is powered by, and GPT itself is a large language model, GPT 3.5 and GPT 4. Like these models are more like dictionaries, and they have their own method of understanding any language that you give in and processing, and after that they are ready to interact. So while for humans, our linguistic took so much time, I think for computers, there was a 50-year period, and we will go into details of what happened during the 50 years. But once they passed through that age, it was very, very quick for them to understand. Now, initially in 1960, I would say, I think one of the popular one, while NLP has been there since 1954 or so, the Rogerian therapist Elijah was quite a popular model that came from MIT, where the idea of this chatbot was to help the patients with certain answers. So these are all lexical methods in the initial. So they use some symbols and to figure out what is the question that is being asked, and there are huge set of templates. Answers are all pre-coded. So based on the question that they get, the answer is predefined, and that answer comes. And they also use some symbols like keywords. And if a particular keyword is present, then they rephrase the question in Elijah. You can even check, I'll share this, I think Blackbucks will share these slides with you. You could try out with Elijah. So the initial period was more around the lexical methods. Now, so I think till 1970, 75, the situation was similar. So at this time, there were also efforts to distinguish a word based on the parts of speech, whether it is a noun or pronoun. If it is a noun, then how should it be handled? All of it was pre-coded and available. Then in 1990, you see, from 1980, 85 onwards, these words started having some numerical representations. So it began with the numerical representations have begun with one-hot encoding, where let's say in our database corpus we call, right? In our corpus there are 10,000 unique words. Then we have a big vector of 10,000 dimensions, and every word will have a distinct position. For example, in this case, what? And we'll take the same example that is available here, 8 dimension, I think 3, 6. Yeah. So let's say the corpus here has 8 unique words, and the first word what has 8 dimensions, with first dimension has a value and rest all are zeros. Rest all are 0 values, and first one is 1 value. Now, if you look at these 8 vectors, right, they're all unique. Now, so this is how one-hot encoding has started. So compared to working with text and making a reference to the text, we moved to numerical representation of these words and started looking for such numerical representation. What is the advantage of this method and what is the disadvantage? If anybody could write, say.
Advantage is every token has a unique vector.
Yes.
Disadvantage is they are highly sparse, and they take a lot of memory. For every token, vocabulary size vector is that much, and there is no notion for similarity.
No notion for similarity. Yeah, I think
they are highly orthogonal.
Yes. Yeah, agree. So I think very well said. One is, I think the advantage here is in computationally efficient working with numbers. However, disadvantage is also due to sparsity of the data. So many zeros are there. So initial early responses to handling the sparsity was using principal component analysis, where you reduce the number of dimensions. It's also black box kind of thing. However, you are making more denser vectors using principal component analysis. Yeah. So the subsequent methods today also, our language models rely on the vectorization of words. We will go into, however, they are much more smarter vectorization and not one-hot encoding. We'll go into details of it. Yeah, 80 and 90, there is a good amount of improvement in terms of even universal terms and entities being defined and so on. Now, from the representation, numerical representation, in 2010, we are exposed to more of neural network based methods. Now, here in the vocabulary, each word here has it still has a vector. However, this vector is smarter vector, little more smarter vector, where it is one densely positioned. Unlike, let's say we have 30,000 words. Today, if you look at GPT, there are 32,000 unique tokens, unique words it has. And the way we get these 32,000 unique words, because the dictionary may not have, is these are broken into tokens, all plurals, or ing, ly, etc. They become ing and ly are separate tokens, comma, full stop. Any symbol that is there becomes a token, therefore it's large number. Had it been one-hot encoding method, then your vector size would have been 30,000, 32,000 dimensional vector size, which is computationally crazy to handle, and moreover, it is way too sparse. Now, there are methods like word2vec. We'll spend some time tomorrow to look at how it functions. Word2Vec or Glow, which started in 2012 and 13, 2012, they came up with. They are more densely positioned with superior understanding of a word. They were also able to get meaning of a word to an extent in that. Details of Word2Vec here, and tomorrow we'll spend some time how the intuition behind Word2Vec, how exactly it works. But then in 2017 there's a big shift that happened. Courtesy Elmo, this is Allen Institute who has come up with a model called Elmo. But I think what is important there is they started at an attention on the top of a recurrent neural network. Would you be familiar with recurrent neural networks in deep learning? Yeah, I think.
Yes, sir.
Okay, fantastic. So in the recurrent neural network, I think a lot of advancements have happened. One was initially it was only left to right. So only progression was left to right. Subsequently, it became bidirectional. And then there was an issue with the initial words were having very less memory by the time we reached the last word. And therefore, long short-term memory has come. Even if you do not pick up these views, it's not a problem, because there are only few applications that use RNN, and the current age of LLMs, it is not essential. I'm only probably trying to throw some history here. Then long short-term memory, time series issues, time series problems, machine translation problems. Still, sec-to-sec methods have stronger capabilities to respond, sequence to sequence, these LSTM methods, long short-term memory. I think the advancement that they came up with was on the top of an LSTM model. On this, they have created attention so the last word had a probability relation with every other word in a sentence. And they said this attention was providing some sort of a probability of word occurrence, next word occurrence. And that became a basis for Google researchers to come up with transformer architecture. It was in 2017. Transformer architecture is worth to spend about 20 to 20 minutes or so. We will look at the maths behind that day after tomorrow. Now, the important aspect is they wrote an article we shared with you as a pre-read. Attention is all you need. So they say that the recurrent network where the data is progressing one after the other from word to word is not that important. What is critical is having that attention. So they built the whole transformer architecture, and they highlighted attention is very critical, and very critical. Around the same time, we have these pre-trained models. Today, I work in the chatbot space. If we have to build a large language model from the bottom up is not a pragmatic thing. Infrastructure is heavy and accuracy cannot match to where we need. However, we have a base, and on the top of it, for different tasks, we use our own data. We call it as, now we use a retrieval augmented generation method, RAG. We'll talk more as we progress. So 2017 gave birth to transformers and subsequent innovations. So GPT came in 2018 July. BERT came in 2018 September, though BERT subsequently, only in 2019 they presented a paper and so on. So today, a large language model is more like a dictionary. And any of us, if you want to work with software where we want to create a chatbot, or we want to do language translation, or in any of the language processing capabilities, we take the existing model and we either fine tune it from bottom up, or we use our own data at a surface level and try to get response. I'll just give a pause here on the history. Any view to where we are, or any question?
Can you please elaborate on RNN, sir? Just brief.
Yeah. Sure. So I'll use probably. So very quickly to share, we have the screen is reasonably clear, right? This whatever you see there.
Yeah, yes, sir.
Yeah. So what we have happened, we have created artificial neural networks. These have suddenly introduced more weights, because until in machine learning, whatever let's say input were there, if the number of inputs x's are only 3, x1, x2, x3, the number of weights we used to have only 3 weights. In artificial neural network, there is a layer that is being created with some sort of new variables here. Let's say 2 variables are here, and all of these have added value to it. Some portion of it has come here and then that moved here. So in the process, what happened is we got another weight here, got added another weight here. So weight 4 and weight 5 also came in. So like this, we kept creating more layers and so on. Now this data, in case of text, right? Text has, let's say 100 dimensional, let's just take 10 dimensional word representation. Now, if you have to put a sentence 10 dimensions, one below the other, all 10 dimensions, and then below that all other 10 dimensions. So here we don't have a real understanding of each word, and when a word is coming, and when a word, what is the sequence of a word in a sentence, that is not clear when you keep in a flat network. So the advancement that came up was, let us create some sort of a, every word will go through certain transformation. Let's say this is NLP class. This is, I'm just writing NLP class. So we have 4 words. So first word goes through certain processing here. So typically, each cell here has 2 jobs, like human brain cell, the neuron, where it takes the data input from all of you. So sigma. So the data is taken, and the second is it quashes the data. It transforms so that computationally is efficient, and at the same time you don't lose. So similar processing that we do here, we use very unique here in RNN. TANH, these are called activation functions, and I'm guessing you would be familiar with activation functions. Generally, you are likely to be familiar with activation functions like linear function, or ReLU. ReLU is rectified linear unit, and leaky ReLU. And very popular is softmax function, which is like our multinomial regression, whatever we use. Softmax function is quite common. Now in RNN we have TANH. If you want to know, I think we can spend some 10-15 minutes later in one of the days. The current methods are super good. There are 2 new methods: gated ReLU.
Gated recurrent unit, GRU. Am I correct?
GRU is, yeah, in the RNN. In the RNN, advancement of RNN, these activation functions, there is one gated ReLU. So, and then last year, I think 2021, later, somebody came up with another very good activation function. We can look at, I think these 2 are of use for us to know more, which are not commonly printed in textbooks. In any case, RNN goes through those activations, and every word has a set of processing. Now 4 words, we have the data, right? So expectation is this is NLP class. So is this, let's say, is this NLP class? Is this NLP class? And answer is yes, it is NLP class. This is the expected answer. Let's say this is what we need to figure out. Now I'll just go probably change this slightly differently. So this is this NLP class. Now what happened here, couple of things that we spoke. Each word is going here. Now word, obviously when I said it is in 10 dimensional, it is a 10 dimensional vector that goes. There are some amount of processing that is happening, quashing, and that data goes here. This data gets concatenated at the bottom and goes through certain steps inside and passes it. I will put it like this. Basically, in this process, we have a co-occurrence understanding. So we have some knowledge of the first word till the last word, because we are always predicting one word after it in a sequential model. Yeah, I think this should be helpful. So is this NLP class? Class is the last word, and expected answer for this is yes. So what is the probability that after class yes will come? And given this background, the expected answer after yes is yeah, it, and after that is, and after that NLP class. Let's say these are the expected, and then end of the sentence. Now, for this flow to occur, right, in the recurrent, so it keeps recurring this data. So some portion of the data in the past is retained here when we concatenate, and so on and so forth. Did I make sense? Yeah.
Yes, sir.
Yeah. So this recurrent network is being improved in a few ways. And one of the ways is because by the time, let's say if the sentence has 20 words, by the time you go to the 20th word, the knowledge of the first word will be super limited, really very, very limited. Therefore, they created one more long-term memory. So some portion of this original data passes through these gates and so on. So at a high level, it is a recurrent network. But the attention is where for everything there is. So attention, I think I'll talk about here. Now, while computing this value, right, what should be the probability of the next one? This value is also looked at. The probability is determined based on its connection with the first word, its connection with the second word, and its connection with the third word. Third word, anyways, it's connected here. So this attention mechanism is what has given birth to transformer in a way. Okay. Any other view?
Like for example, here if you take that sentence and comparing that sentences, like whether the word is appeared in that given sentence, then if it is visible, then we can give it as 1, and if it is not visible, and we can give it as 0. Is that true, sir? It's like a word frequency table construction, right? In NLP, I'm saying, though it is recurrent network you are explaining. Is this correct? Means you are saying here we need to have the propagation from one sentence to the other sentence, like you are explaining, right? Here in this.
Yeah, correct.
So here is this NLP, means this is NLP class here, like you have took as an input statement. And SCT's NLP class is our answer.
Yes.
So for this in NLP, just I'm giving a kind of, means I'm getting idea on this. This is how we need to construct the frequency table, a word frequency table. Is that true?
Now, in word frequency, there is no relation, there is no co-occurrence coming into picture, right? So it will not, it is not exactly similar. So in a word frequency,
Means
you
you're
have,
saying no, it's like it is connecting with the other statement, like previous statement, first statement, like that. That's how I connected with that word frequency table, as you are saying, word to vector, like just we may move forward also. Just got an idea. Is that true?
it will also have knowledge in addition to the frequency of that word. It also has knowledge of the adjacent words. I'll put it like that.
Thank you. Right,
in fact, sure. Anything you want to say?
No, just I'm recollecting as I'm teaching NLP.
Okay.
Thank
So
you.
let's look at the next step that I want to talk about today. Let me go back to our agenda. So today, what I want to share is how do I slideshow? Yeah. So we will look at overview of NLP and its significance in computer science. Today, computational linguistics really reached a stage, courtesy GPT and other large language models that are based on transformer architecture. We are able to build chatbots or machine translation with very high accuracy. Historical perspective and evolution, I'm assuming we have covered them. Key challenges of NLP, if you see, since 2007, we still struggle with the same problem of not knowing how in a neural network, how each weight, how much weightage it is given to each word in a sentence, that's not really clear. And we are still stuck with co-occurrence matrices. Yeah, here I can use the term matrix here, co-occurrence matrix. So what is the likelihood of, let's say in the sentence, key challenges, space applications of NLP, what is the likelihood of that blank is filled with and? So that probability, and if that is very high probability, rest of all low, that is something which we don't know what else can we do. So that problem continues to be there even today. Introduction to language models and their role in NLP, we will talk about it. Now, there are few things that happened when we moved from lexical methods, the symbolic methods, to more word search. So the terms here I used tokenization, stemming, and lemmatization. We'll talk about each of these. But before that, I will also share. You must be teaching bag of words, right?
Yeah.
So in bag of words, what are you doing? You have, let's say movie reviews. You have a series of comments that you have, and now we have to say whether a review is a positive or negative review. Positive or a negative review. Now, to do this, this text has to be processed. When we push this text, ma'am, whatever you said, I will go by that. Every word, we will convert them into some sort of tokens. Just every word is given a number. We'll give a number to each word. Let's say the movie is very good. So D has one number. Let's say one, movie is 2, E is very good, and so on. And the next one is in this movie, there is lot of violence. So since it is a new word, it becomes 6. This is 7, and since movie is there, it already has a number associated, that is 2. So like this, every word is given a number, and these numbers, let's say all of these are words, word 1, 2, 3, 4, sorry, and so on and so forth. Let's say word N. Here I'll keep word N. Now, this is a word matrix, and here in every observation here, I'm going to make the frequency of it. So this is come here 1. Movie, how many times it has come, it's also 1. So like this, I will keep a frequency of the data. So when we are doing it, there is a small problem with the English. We have, let's say, continuous tenses are there. So when you have ing, so it is like run and running. So run and running are somewhat similar only, right?
Yeah, but it is having the yes.
Yeah, there's a tense. Now, if we have to, so to bring some sort of a similarity in this, we started stemming these things.
Yeah, stop word removal, right? It is.
Yeah. And stop words. Stop words. What are the stop words? Words.
A and B. Oh, sorry. Carry on.
Perfect. Is.
And the are like that we can say. No?
Yeah, all vowels, the, and so on.
Yeah.
The words that occur very frequently, and the word will not give so much of distinction to determine what class it is. So these words that do not carry a lot of value to differentiate between whatever we want to classify, all those are. So finally we came to all these vowels and is, was, then so on have become stop words. So stop words are being removed. They cannot determine whether it should be positive or negative. That's one happened. Second thing is between run and running. Here, these are similar. So run, or for example, we say, an example could be going. So
play,
the person,
playing, like that we can take. Play, playing, like that.
Yeah, playing. Yeah, he played, and he was playing, or and so on. So these have similarity in the meaning, and therefore we started stemming them. Remove these things and have that core word, dictionary word, as a important word here. So that's a term called stemming you did. These are all, see, at the end, we didn't change our method of keyword search. However, the keyword search became super smart by 1995, 2000. This keyword search became quite smart, courtesy these methods. The third method, stop method, stop words are there. Then you have lemmatization. Lemma is lemmatization. In lemmatization, we remove plurals. So here we call probably dictionary words. So if there are, let's say, apple and apples. So S is removed, the plurals are removed, tenses are removed, and the plain words are kept. So these lemmatization and stemming typically are done together. And stop words, thereby the unique words are provided here and the frequency of it is computed. Now, once we have the frequency, suppose in this case, you will have a lot of sparsity, because if you have, let's say, word N is 80 unique words in the movie review, so you will have a lot of zeros in many places. And the way to address is, like I said, you could use one of the methods. PCA can be one method. In any case, these also 1, 2, 4 frequencies could be reduced, and there is one popular method. These term frequency, terms are nothing but the words, can be inversed, TF minus IDF. So yeah, inverse document frequency, you can say in that document how many times that it occurred. So you do a divided by, or there are different methods by which essentially you highlight words that are very rarely appearing in a document in a particular observation. So you highlight and you give more weightage. Stop words you anyways dropped. Within the keywords also, if you have a word that is occurring more number of times, then it can't be a good differentiator between the two. How did I come up with this statement? Let's say you have 10 variables and you are doing some linear regression, 10 variables you have, and you are trying to identify the person's weight. This is my favorite example. These are all the profile of a person, and weight you have to determine. In this, you have one of the parameters, though funny, is the color of dress. So you have 10,000 observations and you have color, and generally the color of dress, let's say there are only 3 colors commonly being used, and it is so common, those 3 colors appear so frequently, then it can't really differentiate to get weight. A very rudimentary example is serial number. Now, serial number is unique for all of them. So this is another opposite side. So it also cannot differentiate which weight it is. So in this case, we do the inverse document frequency because that it is occurring so many times, and so on. So the 3 things that here we have done in the bag of words, while these are keyword search, we have removed stop words. So we have fewer words that came. We have done the stemming, removed those extra words and kept only the core word, and we have lemmatized. So all these words are now here as critical. So now each of those words carry some value, and you will see whether you're positive or negative sentiment. Just give a pause, and this is how machine learning could do the natural language processing, NLP.
Sir, can I have a question? It's
Yes.
doubt only. As you are saying about TF-IDF, term frequency, can we take here a document, kind of, for example, if I'm searching in the Google by giving the phrase as, what is NLP? This is my query over the web. And it is generating several URLs, like set of URLs 10 to 20. And out of which I can take accurately what is NLP, only the URL, like, and next URL it is giving like how it is working, what are the applications, and what are the NLP tasks, advantage, disadvantage, like that 10 number of URLs will be given. So here, what is NLP is my query. For the term frequency, if I take those URLs as documents, so can I say out of 10 documents, only 1 document is giving the accurate answer? Like we can say here, metrics we can add here as a precision and recall, right? So for term frequency, in order to calculate that. Oh, so that among the 10 documents, can I say one is having only the precise answer, accurate answer, like. And coming to the idea of inverse document frequency, so there out of 10, only 1 is giving the answer, or else second one also giving the exact 95% answer, like for that 2 if I am taking. So can I say here it is inversely proportional to 2 inversely proportional to 10, like that we can take, what is that formula? Could you please?
Probably I will cover the formula right now. We have got term frequency is clear, right?
Yeah.
How many times a particular word has come. Now in this document, how many, across the documents, let's say here 10 documents you spoke about. Across these 10 documents, how many times that word has occurred? And let's say this word occurred across documents 20 times. And you are doing 1 by 20.
Yeah.
This is one of the methods, and I will also probably give a piece of code tomorrow where you get to see how, let's say, a GenSim or NLTK classifier, how it does. So you get a very small value here. Now, if the number of times it is across documents, only 4 times it occurred. Now, let's say though it is 1 here, 1 by 4 has higher value vis-a-vis 1 by 20. Do you see the difference? So
Sorry,
this is
come again, sir.
Now I have taken 2 examples. One is, let's say, a movie. Movie as a term occurred 20 times. Yeah. Another one is fantastic. Fantastic occurred 4 times across all the documents. Yeah. Now, in this particular document, the observation, I'm calling it as document because that's how we said documents, right? So in this observation, in this document, the term movie occurred once and the term fantastic occurred once. However, when I'm doing inverse document, I'm checking all the documents and seeing movie occurred 20 times and fantastic occurred 4 times. So I'm doing 1 by 20 and 1 by 4. The value here 1 by 20 is 0.05, right? And here the value is 0.25. Do you see any difference? Now 1 became 0.25 and 1 became 0.05. Do you see any difference here?
Of course, sir. 0.5 means 1, like we can say 0.05 means 0, like we can. It's a kind of recall and question, like we can say, if I'm wrong.
Fantastic. So because this is occurring very rarely in the data, this is made prominent. Let me also check the standard TF minus IDF. What are different methods in which we can compute, and I'll share that in the next session.
Yeah, sure.
Yeah.
Thank you.
Broadly, this is the intuition here. Okay. Now, Venkatesh garu, please go ahead. Any question?
Actually, this concept comes under information retrieval systems, no?
Yes.
IRS. So with that idea, I asked because even I taught that subject also. It's a combination of, because this is a prerequisite, right, sir?
Yes. Yeah, agree. It comes under information retrieval. So here, how do we unmute Venkatesh garu? I'll check.
If you are a co-host, you can unmute, sir. If madam is a host, then she has to make you as co-host.
Okay.
Hello.
Okay. Yes, you're all set.
Sir, this is Venkatesh.
Yes.
Sir, generally in NLP, we are mainly focused about remove the stopping words.
In the past, yes.
Yes, sir. Okay, remove the stopping words. But in case without removing the stopping words, what will happen, sir? Is there any decreasing? Is there any probability is there changing?
Yeah.
Why? Because in generally in lexical analyzer, we are mainly focused about comma and full stop. That's different things. Generally, is a program lexical analyzer in a compiler design, what it may be. Lexical in that we are mainly preferred like a comma column like that also. But
Correct.
here we are not considered that one. We are mainly focused about is, am like that. But these are also sometimes treated as a verbs.
Agree.
It is also changing the word now. That's why I'm asking. Okay, sir.
Okay, so I think prima facie we need to keep in mind
Yes,
in
sir.
the NLP today, I am not aware where anyone is using bag of words methods. These
Yes,
are
sir.
very rudimentary method. You are right. The problem is, see, their logic that they had is not able to differentiate whether it is a positive rating or a negative rating. Therefore, we will drop them out. It is like occurring very frequently, and but it is not really telling positive, negative. Today, your view is perfect to me because sometimes comma brings that value. Is and was is telling whether it is present or past. So that data is useful today, and therefore today we don't drop any word. Everything is being used in the language models. It is for us to understand how we evolved to the numerical vector before looking at the word as a numerical vector. Today still we are living with numerical vectors because I think we don't know how else can we make machines converse with us comfortably, so we stuck to numerical vectors. I want to highlight this point. The NLP we can discuss in 5 different dimensions. The whole of machine learning is math. So one option is that we stick to the math of it and we can run with it. So it's just beautiful. This is the crux, how it works.
Yes, sir.
Second option is we can look at, because we have a lot of information to be covered, maybe we could skip some bit of math and focus more on um, how how evolution has happened, what are different models, and at a high level, what is the framework of a model. I'll be able to talk about the framework for BERT, framework for GPT, and we'll invest some time around how GPT is different from BERT kind of models, where each one has strength and so on. So keep spending time over here. Third way is focus on code. We can have, so we can have few, see, a lot of what we discuss, right? Math, now it's all simplified courtesy. We have transformers, we have TensorFlow, and all NLTK is barely now being used. So these are all pre-built, and we just write few lines of code and run with it. This third way of looking at. The fourth way is to see what does it take to deploy these models. So what are the deployment challenges, integration challenges? So developing a model takes only some bit of effort. So this is another way. And fifth way is focusing on how do we gather and process data, or what are the challenges today. The world focuses primarily on performance of a model, looking at F1 score or details of precision or perplexity, accuracy of the model is viewed. But then bias, ethical considerations, these aspects are not emphasized as much. So should we look at how do we really evaluate the models? How do we gather the data? And so training a model, right? So the problem, if I don't know, if you ask GPT questions, sometimes it throws some random responses because it is trained on a massive, some parts of it being garbage. So massive data, some part of it is not relevant, and therefore whatever you give as an input, you get that as an output. So we should not be surprised. Only now the world has moved towards now, I mean, in the last one and a half year barely, we have moved towards labeling the data complete, all sanitized, humans providing the instructing the model, giving the cleaned up data. So the fifth way is focusing on evaluation, looking at what data sets we should use for training the model, what data set should we use for evaluation, and so on. So which of these 4 do you prefer we focus in these 4 days?
Okay. Okay, sir. Thank you. So that's why I am asking means whenever we are removing these type of, we are facing so many problems. Ambiguities problem is there. That is one of the crux of the NLP, na. So that's why I'm asking. Okay, sir. Thank you.
Yeah. So my question to all of you is, which one do you like to spend more time on? You want to focus on math, or you want to focus on frameworks or code or deployment challenges and considerations for each of them, or gathering data and evaluating the models?
Gathering data and evaluating. But the pre-processing very difficult.
Okay.
That's my opinion.
How about others? Okay.
Math and deployment, sir.
Math and deployment. Okay.
Deployment, sir. Code also. Both.
Okay.
Last one, sir. That is gathering and evaluating.
Okay. Sure.
For the rest of the things, we'll get the videos and everything.
Okay.
But for this one, we need a little bit more keen observations, I think.
Sure. Sure. So good. I think a math and code. So I think clearly the focus appears to be how do we gather data to train our models and how do we evaluate. I think we will spend a little more time on this. While we will also look at so there are certain interesting elements where we could potentially look at math. The aspects that we should consider are, so I think I understood the primary focus areas, but the math that we will see, one, we need to know pattern recognition. So for pattern recognition, how are we doing? Second is we can look at a loss function. One or two loss functions we can spend time. And third one, we can see back propagation. I think back propagation is something which is critical. I think if we can get a good understanding of back propagation, that should help. Finally, we will also look at some architectures, 2 or 3 architectures we will look at. So these will be our focus, and I'll spend more time otherwise on which data you need to get and from where you can. So Christopher Potts teaches NLU. I found his photo in Wikipedia, but I think he emphasizes a lot around the right data sources that we can use to build the models, and also what are the evaluation methods. So I will send before our next class certain common, there are 7 or 8 evaluation methods. I will forward those details to you. Yeah, it's perfect. Now let's look at stop words removal and text normalization we looked at. And named entity recognition, I think we will run it probably with a code or so. I will share some details that I have. When you are teaching NLP, what are the models that you teach? Okay, so at a high level, I will say that transformer architecture is focused on attention. While we will look at the architecture later. So this transformer architecture has 2 parts. One is an encoder and second is decoder. Now, encoder models focus more on understanding the text. It's more about NLU. So decoder models focus on NLG. So these are terms, and anybody wants to give example of encoder based models? Okay, encoder based model, one super powerful is BERT, bidirectional embedded representative transformers. We don't need to know full form. However, BERT is one, and MPT, since we use MPT and E5, these are powerful methods where here they can process the text and understand the question that is being asked more effectively. Okay. Oh, nice. Excellent. Yeah, CNN is outside, but perfect. So these are all transformer architectures. Very well said. Now, the decoder are generation oriented, natural language generation oriented, and examples are GPT. GPT is one example, and Llama 2. Okay. Llama 2 is another example where we have. Now, interestingly, what is happening with the decoders is these are also called auto-regressive models. So when auto-regressive, when we say these models, every time, once they predict a word at a time, so predict a word and use that word as an input in addition to the rest of them. So this I will keep here. Let's say in the previous example, I'm jumping here. In RNN, every time we are predicting the next word, we have the remaining data being available. So if we are analyzing all of the data again through attention and predicting the next one, then we can say auto-regressive model. So GPT and Llama 2 are auto-regressive models, and this became popular.
Excuse me, sir.
Yeah.
Sir, what about word-to-vec or auto-encoders that are used in deep learning? Will they come under this encoder-decoder transformer architecture?
Oh, yeah.
Auto-encoders or word-to-vec or node-to-vec?
Yeah. So these word-to-vec these are all distributed representations. So we call them as vectorizers. You're vectorizing the data. Now, when you are vectorizing the data, we don't even use deep learning. You can use in neural network methods. However, it is not essential that you develop a vector. You generate a vector using word-to-vec with the neural network architecture. That is one. Two, encoder and decoder are a function of transformers. I wish to share transformer separately, but I'll see if I have. Yeah. Oh, this is crazy. This is a lot of text. Please ignore. Just focus on the central part. Yeah. So you just focus on central part. In the transformers, you have an encoder and a decoder. Two sides, right? The left side is the encoder and right side decoder. Now, whatever focused more on encoder side where the training happened, these are meant for NLU. Whatever used the decoder architecture, these are doing better in natural language generation. Now, word-to-vec, they did not use transformer architecture at all. They use either neural network methods or much simpler machine learning methods were used to compute the dimensions of a vector.
Word embedding comes under decoder or encoder, sir.
Like, can you say here stemmer vector photo-stemmer algorithm also there, right, sir? Photo-stemmer algorithm coming to word-to-vec, no?
I am not familiar. You please ping that, madam, in the group. I'll check what you referred to. So embedding.
Word embedding, it comes under encoder or decoder, sir.
Embedding means a vector only. It is a numerical representation of data. See, what is a vector for us? So let's say a 10-dimensional vector we say. So a word is represented in 10 different dimensions. So 1, 2, 3, and so on, and 10-dimensional vector. So you use the term embedding because it is in a numerical fashion. So you can say embedding, or you can say a vector representation, or you can say distributed representation, because in these 10 dimensions, right, you will also look at the position of a word in a sentence and where exactly it is coming in a sentence, let's say. So essentially, embedding is nothing but a numerical representation of a word.
Okay, sir.
Yeah, I will check. So if it is for stemming, then it is part of machine learning. It is not using deep learning or transformer architecture at all. So this is more advanced, than it is not included in machine learning at all. Encoder decoder comes only in the transformer. So all right, now let's go to the auto-regressive models that we said, right? Now you will also be hearing today reinforcement learning. Right. So reinforcement learning is the one that made difference to the large language models, because until 2 years ago, until 1.5 year ago, we did not have reinforcement learning in the large language models. So, for example, let's take BERT. BERT is trained on I think 1.5 billion words. So they had some 700 or so, or 1.5 to 2.5 billion words. I don't remember exactly. So they had some 700 million or so coming from Wikipedia, and then remaining 800 million, I think it is 1.5. Remaining 800 came from books. Primarily, Canada Press has provided. Now, what they did, they pushed all of this data into this transformer, some sort of an architecture that that y is equal to f of x, right? That approach, f of is some approach that they have got, and all the words have got a numerical representation. So this representation was 768 dimensions. So the BERT was of 768 dimensions. Now, when we ask a question, right, the answer that comes from, generally it can't give an answer. You have to give your own data, fine tune. The answer that you get is based on its learning from these Wikipedia and 800 and books. So this answer is not necessarily correct. So am I making sense still here?
Sir, about dimensions, it is like the number of words. Is it like number of words in the entire Wikipedia? Do you consider it as dimensions? What actually is a dimension? Can you please elaborate?
Yeah, let's say we live in a three-dimensional. Let's say x and y, right? So you have some coordinates, distance and time, and say this is the point 3, 4. Let's say this is you are looking at length and breadth. What is the length of a plank? What should be the breadth of a plank? And you say that so this is small. Let's say what it's an eraser. What should be the length of an eraser and breadth of an eraser? Say we say 3 centimeters by 4 centimeters. This is a 2-dimensional vector. Now you can say, what is the depth of the eraser? You can say that, look, it has to have 1.5 centimeters below. So 1.5. I'll simplify it, 1 centimeter. Now it is a 3-dimensional one. Till here, did I make sense? If I want length, breadth, and height of an eraser. Ma'am, till here I made sense?
Yes, sir. But in NLP, how is it the dimension?
Now, when I say this is a 3-dimensional vector, in NLP, each word, right, an answer, a word, name, let's say name or hello. Hello as a word is represented in 10 dimensions. So you will have 10 different values for hello as a word only. So each word need not be an integer, it can be float also, and each dimension can be a float value, any value that is there based on whatever method you used, word2vec or glow architecture or any of the deep learning architecture, this 10 dimension. So that's why I'm saying the BERT has got 768 dimension, or GPT earlier has 1024. I need to check the current ones have what dimension. GPT-3 does it still have 1024 dimensions or more? So it is all a single vector for every word. Every word is represented in these number of dimensions.
So those dimensions are fixed, sir? That 1024 or 768, they have fixed and designed the BERT transformer.
Yes, yeah, that has to be fixed. Now, in how many dimensions we want to capture each word, and each dimension, right? I wish I had planned more things today itself. So each dimension is like one dimension talks about distance, another dimension talks about gender, then third dimension talks about location. Roughly, I'm saying fourth dimension talks about nations, and so on. So, and then it's fifth dimension talks about sea, land, inland, and so on. So each dimension has some data reference. So for every word, the dimensions are fixed. Is this fine?
Yes, sir. Thank you.
All right. So now what happened, we have some of this data is not really relevant and so on, that caused trouble. So particularly in GPT-3 was announced on November 15th, they have mentioned they used reinforcement learning. They used humans to evaluate what the model is responding. And once the humans evaluated whatever model was responding, if it is correct, it has given more weightage to such answers. When it is wrong, it has given less weightage to those responses. So that way, the model became stronger. Now, not only this is built on the large corpus you provided. In addition to that, we also have human feedback. So they had, I think, each domain had 1,000 or more questions, and it all had labeled answers were available. The question was asked to the machine, to the model. When it gave answer, it was clarified whether the answer is correct or not. So if it is a wrong answer, then it went and updated the weights of the model. So the second important, or along with the dimensions here we spoke about, the another important aspect is number of parameters of a model. So have you heard of parameters of a model? Parameters or weights?
Weights.
So this is the output, right? From any model, what you get is the number of parameters. Now, so these parameters have kept on increasing. They kept on growing more and more. Well, let me see what I can show now. But yeah, so the more number of parameters, it is likely to provide more accuracy, and less parameters, not as much. Let me quickly share more details. Any questions so far?
Could you please brief on again bird model only by taking one example like animal, cross, bee, street, because like that with the some words like.
And you want a bird to be explained? Sure. So, okay. Let's take in the bird, we are saying it is able to understand. Let's say it is a movie rating. We will keep a classifier on the top. The bird is an encoder model, and each, let's say there are some set of words. In the movie, the lead actress had played a significant role. Let's say the lead actress played significant role. Lead actress played significant role. Now, if I have to explain how in BERT this is translated to identify whether it is a positive sentiment or negative sentiment. This is what I should do, right, ma'am?
Sir.
Okay, so now in this, we need to look at this is T is meant for transformer architecture. We can go into details later. Next, ER is embedded representations. So each of these words are converted into a large vector, multidimensional large vector. That is so 768 dimensions, whatever we are talking about. Now, B stands for bidirectional. So which means it will check from this side as well as this side. Okay. Now what we are doing, these numbers will go through, the first step is called positional encoding. Now we need to know that lead is the first word and actress is the second word, and played third word, and so on. How do we know which one? You can use different methods. One of the earlier methods is using the sine values. It's a sine wave. So there is a crest and a trough. So use the sine values to compute. Now it is relative contextual words, relative contextual methods are being used. A rotary positioning is another new method that has come. In any case, we will figure out with another vector here what is the sequence of a word in a sentence. That's the second step. third step that we go through this data is little heavy, madam, multi-headed attention it goes through. I'll simply keep it as a big block. I will say that every word, this particular word has reference to all other words. So we call this as, so if you teach word to vec, you know what is a center word and what is an outer word. So keep center word is for every word that is a center word, and others are all outer words. This is, let's say, T, then timestamp T1, T2, and so on. Whenever you are doing, let's say, T3 and so on. Played, if you are doing, then you have T-1, T-2, and T+1, T+2. And you can also clip the dimension here to maximum not more than 2 on either side. And then even if it is finite number, a big number, still it will be 2 only, timestamp. In any case, the attention that we are bringing is here we are computing this vector value against all other values. And now it passes through, simply put, a multi-head attention, and you have layer normalization. You have skip connection and layer normalization, and feed forward and the layer normalization at a high level. And I will definitely explain details of this day after tomorrow. So it passes through, and finally on the top, you'll have multiple layers like this. You take the output and see this particular one has what probability of plus and what probability of minus, since it is a classifier. And let's say we have this being a positive one has probability of 0.7, and this being negative is 0.3. So which one do we choose?
Maybe it's positive, sir.
Correct. So high probability, right? Since it's binary, you have to, if you have multiple, let's say 32,000 words have to come. In this case, it is positive. So the answer is a lead actress played, what did I say?
Significant role. Lead actress played a significant role.
Thank you. Lead actress played significant role. So yeah, lead actress played significant role. I watched a Hindi movie, I don't know, Ranveer Singh with Alia Bhatt. What is the movie? Yes, Rocky or Rani. It's an amazing movie where how the typical Indian mindset is being shown and how a woman can really be empowered. So unique, not so common in Indian movies, a woman getting lead role. That's where this comment is. In any case, so it is a positive sentiment. So a couple of things you observe here. Forget about this architecture here. Here, everything is converted into embeddings. These are all vectorization is embeddings, and you have a positional embedding also. Then it goes through a lot of transformation. Finally, you have a classifier which is giving probability distribution. This has 0.7 probability. This has, let's say, 0.5 probability. Negative being 0.5 and positive being 0.7. So then, therefore, we declared since higher probability is plus. If you are trying to predict, let's say, lead actress played significant, and we don't know the next word. We want to predict the output as what is the next word. Then what is the possible options that we have? The question I asked is lead actress played significant. Now we need to predict what will come as a next word.
Role.
How many different possible options are there?
Like it is about significant role played, played a significant role. That's how, sir.
All the words in the dictionary are a possibility. So since here 28,000 are there, 28,500 or so in bird, those number of tokens, those number of unique words, unique vectors are present. It could be any of those 28,000 words. Now it's the question is which has highest probability, and possibly role may have 0.85, which will be highest probability compared to remaining 28,499 words. And
sir,
therefore,
is it actress and role, sir? means highest probability as you
Correct.
asked.
Yeah, that is what I'm widely guessing, because lead actress played significant. Now, role should have highest probability, and therefore it should answer it as the last word is role.
So that's how we can predict, right? Like means
Huh.
what we are describing about.
Correct. Humans are predicting, but now you want machine to bird to predict, right? What should be the last one?
Oh, here I said about actress, like according to your sentence.
Huh. Actress.
But what is the kind of verb we can use as played? Played.
Played. Huh.
My guess it is.
Say it again.
Played. Actress played role. Or else if we take individually only one word, if you want to add means significant, like what kind of the highest probability, like we can say.
No. The question here is lead actress
Played a significant role.
Played a since I didn't write a while it was correct English, significant blank. Now we expect model to bird to give us an answer. First, what did I say? Yeah, before this, what did I say? The output is movie is whether the movie is positive or negative. To figure out whether a movie is positive or negative, what it has done is, based on the sentence, it went through so many steps. Key steps that I highlighted here are only two. One is you convert each word into an embedding, identify its position, and pass it through some transformation. And finally, the head will be whether it is a positive or negative. And then it gave for positive 0.7 probability. Likelihood of it being positive is 0.7. Likelihood of it being negative is 0.5. Between these two, high probability is for positive, and therefore you said this particular rating or this particular feedback about movie is positive. Till here it is fine, right, ma'am?
Yes, sir.
Okay. Now, next question. This is a normal way that we do it with bird. Now, the next question is, let's say we have 4 words and we want to know what is 5th word. Lead actress played significant. So we don't have this part. We don't have this part. We have these 4 words. We passed it through this transformation. The output head can have 28,000 different possibilities, because in bird you have 28,500 unique words. I can recheck the exact number. I know in GPT they say 32,000 unique words. And told you it is about tokenizing. They also cut lying, stop, full stop, comma. Any symbol has unique word. So all of them are possibilities as the next word. But then role may have very high probability, and therefore you select role as the answer here. Lead actress therefore is considered as significant, and here you say role.
Probably is calculated from the training. It is
What is the n-gram model, sir?
It is an n-gram model, yes. It is now the whole sentence, and also here the n-gram is limited. You can have maximum of 512 only. 512 words. What happens if you have more than 512 words in n-gram? You truncate it. More than 512, you truncate it. You're saying so?
Yeah. The probability of role got calculated based on its prior training, is it?
Correct. Prior training. And the training was, we mentioned here, where you have a large corpus of data. And I also said in the large corpus of data, it is picked directly from internet, some of it, Wikipedia. Some of those sentences may not be meaningful. Sometimes it can give wrong responses. Therefore, reinforcement learning was introduced. Reinforcement learning had human feedback. Humans have given some 10,000, 20,000 questions or so they give, and then they also know the answer. They expect model to answer. If it is not correct, then it will say, then it will go and update all the weights. Now there is a question. Yes.
As you have taken, this is an input statement. So you have given us the role is our output like. So why it is only role? Because you are saying that referring the other statements, like you took as your T1, T2, and later you took as a T minus 1 and the next iteration onwards. So could you please?
Okay. Yeah. I will share greater details of that positioning. Maybe I'll explain what to vec or maybe transformer itself. We'll see. So what I said there was there are 4 words. In these 4 words, we'll explain it completely in the transformer architecture, ma'am. Okay. So lead, actress, played, significant. Now I'm saying this embedding, whatever it comes, when it goes through, the value here will also does the dot product with this value, dot product with this vector, and dot product with this vector. You might have heard, those of you who teach transformer, you might have used the terms like query, key, and value. Your keys are nothing but the dot product with adjacent words. Okay, so I use that vector timestamp representation in RNN or word to vec. You normally say a center word is T and the forward words are T1, T2 timestamp ahead, and center word or any word that you are looking at, and behind words that are behind are T minus 1, T minus 2. This was a notation that I used generally for timestamp in the sequence we use. But in case of transformer, it has anyways position of it is already the positional embedding is already included within this vector. Therefore, we don't need to capture the timestamp once again. So it straight goes in. I know it is a little heavier, but then the dot product of it, the query is this lead, and you do with actress, comma query lead into play, blah blah. So all of these dot product, and those of you who know the transformer, what happens? It goes through a softmax. So you do in the softmax, what do? We do an exponential divided by sigma of all the values, blah 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 values. So this is how we compute.
Like key value pair, sir. You are taking query and A means? No, right?
Query, key, value,
Key
right?
value pair, right? It is. Key value pair, sir?
No, that is in dictionary.
Okay.
Dictionaries key value pairs. In dictionary, key means your label name, the variable name. Yeah, value is the observation. So it could be like, so let's say in the human anatomy, the height, age,
Yes, sir.
diet, these are all the keys. Oh, this is different. So I think I complicated here. I will talk about exactly how this timestamp happens. We will run, let me do the transformer architecture tomorrow. And we will also we will review some databases that we can use to train a language model tomorrow. Then,
thank you, sir, for the brief on what I asked the question. Thank you so much.
Sure. So tomorrow, I think word to vec, I'll push it to a later days, because anyways, we don't use the basic methods. And I'm guessing I'll do a quick 10 minutes how this vectorization is happening, and straight jump into transformer architecture, because that is the starting point for today's world, where we'll explain these points. Then we'll talk.
Excuse me, sir.
Yeah.
Sir, the transformers, are able to classify that based on a sentence, whether the sentiment is positive or negative, and they are also able to predict what is the next word. Is it right, sir?
We looked at 2 examples. You're 100% right. On the top of your architecture, whatever output you want to take, you can take. In one case, I said I keep a classifier as my output variable, where there are only 2 possibilities, plus or minus. In another case, I'm saying the possibility is 28,000 words. Now you predict next word. General, in the chatbot application, right? You always look for next word. In the sentiment analysis, you look for positive, negative, or happy, unhappy, neutral. So those kind of things. Whatever classifier you keep on the top, that is what you can get as an output. These are two common illustrations. Okay, so here is what, so today we looked at the machine learning framework where y is equal to f of x. Then I spoke about for any model here, there where we define the rules. The way we do is, one, identify pattern using an approach like linear regression approach, logistic regression, or naive Bayes theorem, or support vector machines. These are all approaches, and you choose based on what kind of y is, whether it is continuous or discrete. Then once you identify the pattern, second step is determine the error. There are different error determination techniques, and third step is rectify that error. So, and the most popular is doing a gradient descent method. You rectify the error in one form or the other. Then we looked at NLP has been there for last 60 years. However, it is very recently that it became popular. One key thing for AI to become popular is data storage and processing, these three availability. Second thing is we were able to identify these vector numerical representation of data is easier to compute and compare. And because of this numerical representation using transformers, we achieved multiple things. And tomorrow I'll share. One, we were able to identify semantic relationship between the words. One example, J. Almamer says, and you can also do that analogy. I'll show that code tomorrow, where if you write, give me an analogy, man to a king, woman to, it will answer queen. Tomorrow or day after, I'll show that a code. So, and another way that you can compute is king minus man plus woman is equal to, it should be able to predict it is queen, and so on. So these semantic relationships it was able to capture. It was able to capture the meaning of a word based on sequence, its sequence in a sentence. It is able to, because sometimes our words could mean different things based on where we use that. So I'll share those examples also day after tomorrow. So we have understood that these large language models have this capability through transformer architectures, and because of which today our chatbots are more accurate. So maybe I'll explain on day 4, Saturday, we will share with you our probably a live solution, a brief demo of, you can ask any question and see how it answers on our QA where we have deployed. So today we also identified, you want to know more about what kind of data sets should you use to build a language model. One, you also want to know what are different methods to evaluate it. While we will focus on these two, I will also share key architectures like transformer and a bit of BERT and GPT. These are key architectures. I will give some math around gradient descent. How do we do gradient descent? And we'll also look at multi-headed attention. I think in transformer itself is good to compute. How do we do layer normalization and dropout? So I will provide that explanation and from a math perspective. From code standpoint, we'll give you Python notebooks. I think in these sessions, we'll share some examples of word to vec I'll share, and maybe a bag of word for how are we computing inverse document frequency, I'll share that. But what is super useful is on day 3, we'll share with you GPT Playground. You all used Playground of GPT? Okay, so on day 3 itself, we will jump to how to use, etc., so that you can focus on that. And then very little about deployment on Saturday we'll explain. Is this fine broadly? Okay, I missed some bit. Sure. So we'll respond later too for any queries. All right, thanks for your time, and hope to tomorrow we'll start sharp 6, and those of you, if you can join that time is excellent, so that we can make use of all to us. Thank you.